So in this class, we are going to be talking about chemical bonding, and in this topic, we look at Lewis model. One of the simplest bonding theory is called the Lewis model. The Lewis emphasizes valence electron to explain bonding. We all know what valence electrons are. So these valence electrons are used to explain bonding in Lewis model. So in Lewis model, these valence electrons are represented as dots. So we're going to see how we do that. Then we draw Lewis structures to predict molecules. When we draw the Lewis structure using the valence electrons as dots, we also call this electron dot structures. Lewis structures allow us to predict many properties of molecules. We can predict the shape. We can predict so many things, and once we know the shape, we can know how the molecule is going to react with each other. So let's take a look at how we draw the Lewis dot structure. So in Lewis dot structure, the valence electrons, as you said, are represented with dots. The core electrons, that is, the inner electrons, are represented using the symbol of the element. For example, we know that sodium has 11 electrons, and in sodium, one electron is the valence electron. Sodium, that is, sodium has one valence electron. So if you want to draw the Lewis dot structure for sodium, we're going to represent the core electrons with the symbol of sodium, which is Na, and the valence electron of sodium, which is 1, we're going to represent it with dots. I'm going to use this as dots so that we can see that. If you want to draw the Lewis structure for calcium, so the core electron in calcium is Ca. We represent it with Ca. Calcium has 2 valence electrons, is in group 2, so we represent the dot as 2. This is 1, and you can say 2. The Lewis dot structure for aluminum would be Al, and it has 3 valence electrons. We do 1, 2, and 3. We have carbon. Carbon has 4 valence electrons. We're going to do C. Then we place 1, 2, 3, and 4. For nitrogen, nitrogen has 5 valence electrons. We do N. We do 1, 2, 3, 4, and 5. You can. It doesn't matter where you start. You can start yours from the top. You can start yours from the bottom. But you need to remember, to take note that whenever you're distributing your valence electrons, you have to distribute all around before you pair. You do not write carbon this way, 1, 2. Even though carbon has 4, you do not do 1, 2, 3, 4. This is wrong. This is correct. We know nitrogen has 5. You do not say because it has 5, you are going to do 1, 2. You cannot say 1, 2. Then you pair it again, another one here, and another one here, and you do another one here. So this is wrong. Right. So let's make sure we remember that. So for Oxygen. Oxygen has 6 valence electrons, so we're gonna write oxygen this way. 1, 2, 3, 4, 5, and 6. Like I said, it doesn't matter what side you side, where you're starting from. Just make sure you fill it round before you pick. Chlorine has 7 valence electrons, so chlorine will be like this: 1, 2, 3, 4, 5, 6, and 7. One thing that is common about the Lewis dot structure for all these atoms, it's that all the elements in the same group, they have the same Lewis dot structure. For example, sodium is in group 1. This is the Lewis dot structure for sodium. If you want to write for potassium, potassium will also be the same like sodium. The only thing that is going to be different is the symbol. Potassium will be K, while sodium will be Na. Cesium will be like same. Cesium will be Cs, and with one Lewis dot structure, and so on and so forth. Bromine will be the same. Like chlorine, because they are in the same group. Oxygen will be same like sulfur because they are in the same group. That is how we write the Lewis structure for the elements in the periodic table. The next thing I want to talk about is chemical bonds. Chemical bonds. Why do atoms bond? Most reason why atom bonds is because everybody wants to be stable. Everybody wants to be like the noble gas. And they can always do that either by losing electron or gaining electrons. By that, they become stable. And we have what chemical bonds is. This is what we have between compounds. The bonds hold elements and atoms of elements together in any compound. So we have different types of bond. So we're going to look at the different types of bond that we have. So we have the ionic bond, we have the covalent bond, and we have metallic bond. So types of bond, we have ionic bond, in ionic bond, electrons are transferred. Electrons are transferred. Electrons are transferred from the metal cation to the non-metal. Remember, ionic bond is found in ionic compound. And ionic compound is from ionic compound, if you look through the previous note, contains metal plus non-metal. Metals are cations, and we know that cations wants to lose electron, and non-metals are anions. They lose electron. So electrons are transferred from the cations to the anions. So in ionic bonding, we say it involves electron transfer. Electrons are transferred in ionic bond. The next thing we're going to look at is covalent bond. In covalent bond, we know that these are found in molecular compounds. And the molecular compounds, we have two nonmetals. We have nonmetal plus nonmetal. They form this covalent compound. So covalent bonds are found in molecular compounds. So in this case, we say that because both of them are nonmetals, which they are anions, anions cannot lose electrons. They all want to gain electrons. So none of them is willing to lose electrons. As a result, in covalent bond, electrons are shared. Electrons are shared. So we need to remember that in covalent bond, electrons are shared because of the fact that they involve nonmetals and nonmetals, two nonmetals coming together. So the next one we want to talk about is metallic bond. In metallic bond, it involves two nonmetals, that is metal, it involves metal plus metals. So in this case, the electrons are pulled. It involves electron pulling. So let's take a look at example of how electrons are shared in ionic bond. For example, we want to show how electrons are transferred in sodium chloride compound. So what we do is we write the Lewis structure for sodium and for chlorine. Sodium has one valence electron. We put it this way. Chlorine has 7 valence electrons. So it's going to be 1, 2, 3, 4, 5, 6, and 7. So sodium is going to transfer 1 electron to chlorine. So that will make sodium to be like a noble gas, which is neon. That is with 10 electrons. And this 1 electron that is transferred from sodium will go into chlorine this way. So this one leaves here and it comes here. Now chlorine is going to assume a stable structure with 8 electrons completed. So when that happens, so sodium becomes like the noble gas that is after it, which is the argon. So this is how we draw the Lewis structure for sodium chloride. Electrons are transferred. When electrons are transferred, in this case, whenever electrons are transferred, electrons are continuously going to be transferred until everybody is stable. That is, until they have an octet structure. Let's take an example of another set of compound. That is, if you want to show how the compound that will be formed between aluminum and oxygen. So as usual, we're going to draw the Lewis structure for Al and oxygen. Aluminum has 3 valence electrons, 1, 2, 3. And oxygen has 6 valence electrons, 1, 2, 3, 4, 5, and 6. Aluminum is a cation. It means it's willing to lose all these 3 electrons. And of course, it's going to transfer the electrons to oxygen for oxygen to be stable again. So let's go. So 1 electron is going to move from aluminum to oxygen, and it comes here, right? And oxygen now has 7 electrons. Then 1 oxygen will leave aluminum again and be transferred to this oxygen. And we have it to be this way here. Now, if you count all the electrons in oxygen, is now 8, because we have 1, 2, 3, 4, 5, 6, 7, 8. Now, oxygen, this oxygen atom is smiling because it's complete. It has 8 electrons. It's good. However, aluminum still has 1 electron here that is making it unstable. Right. It's going to find a way to transfer this electron, and of course it cannot give it to this oxygen. So oxygen is going to look for another oxygen atom to come with 6 valence electrons this way. This is 6, and this 1 electron will go from aluminum here, right? It comes here. Now this aluminum is happy because it has lost all its 3, it has transferred all its 3 valence electrons. However, oxygen is not feeling good, right? Because it still needs 1 more electron. So it's not going to make everybody to be stable. So what will happen is aluminum, we look for another atom of aluminum that will have 3 valence electrons as usual. Then 1 will be transferred from this one to here, and that makes oxygen complete. Now this oxygen is complete. This aluminum has lost 3 electrons to be like the noble gas before it. This one is looking like the noble gas after it. They are complete. However, we still have aluminum with 2 valence electrons that is willing to go. So what happens is we're going to make another atom of oxygen. Remember, we're going to be transferring electrons until everybody is fully happy. That is, everybody has octet structure. So we have oxygen this way, another oxygen with 6 valence electrons, 2, 3, 4, 5, and 6. Right. So this is aluminum here is willing to lose 2, and oxygen, our new oxygen, is willing to lose 2, to gain 2 electrons. So this 1 electron will be transferred here, right? We're gonna have that, and this one will go here, and it forms this. Now this aluminum is okay now because all the 3 valence electron is lost, and here in oxygen it has all electrons completed, making 8. So everybody here is now happy. So we now count the number of atoms of the elements that we have in this. So we're gonna say we have 1, 2 of aluminum, so we say Al2. And we have 1, 2, 3 of oxygen, we have O3. So this is a compound that can be formed between aluminum and oxygen. One more example. Want to do for calcium and chlorine atom. Again, we draw the Lewis structure for Ca. We draw for chlorine. Ca is going to be 2 valence electrons, and chlorine is going to be 7 valence electrons. So 1 electron will be transferred from calcium to chlorine here. So now chlorine is happy because it has 8 valence electrons. However, our calcium has to lose 1. So what will happen is we're going to call another chlorine atom with 7 valence electrons. Right. So this 1 electron from calcium will move into chlorine. Now chlorine now has this 8-octet structure, and calcium has lost the 2. Right, it's okay because it's willing to lose just 2 electrons. So everybody is okay now. So what we do is we count the number of atoms as usual. It becomes, we have 1 of Ca, and which is this, and we have 2 of chlorine. So we have this. So that is how we solve our problems on this. I hope that we can use this to practice how to draw Lewis structure for as many compounds that we have, which are ionic compounds.